Hello. Hello, Krakow. I want to see that you are wake up a little bit after lunch is really hard. So, hello. Perfect. Again, because you are sleepy. So, again, hello. Perfect. We will start with a little question. If you know what I have in my hands, say yes. I know what you have in your hands. Yes? No, yeah? So, basically, this is the electricity socket. I will try to explain you what is the microservice at first, because I think that maybe you can be a little bit confused what is the microservice at all. So this electricity socket is the best example of the microservice, because there is one input or one output which provides the electricity, and you can have multiple consumers who consume the electricity. A microservice is basically elemental part of providing one simple feature. In this case, it provides you power. And you can have multiple people or multiple machines connected to this one. You can have multiple of them. So you can have multiple microservices. These multiple microservices can be in different color. You can have green. Maybe you don't see that, but it's green. You can have blue, yellow, white, whenever. You can have different scaled microservices which are providing simple feature. In the real world, in the software development, it is one small unit owned by a small team of the developers or testers who are developing that in the specific framework, specific programming language, providing one simple function. For example, testing in our case. In our case, we will talk about the security microservices. So our basic security service will be testing the security features, security breaches, and we will use some Kali Linux tools in the microservices and utilize them in automated way. So microservices are automated. Basically, you should be able to deploy microservices in automatic way. They should be built in the automatic way. So they are providing a single feature, automatic way, and automatically deployed. They should be enabled for the messaging. That means that you can communicate between different microservices. Even you need to be able to decentralize them. So they are not centralized. There is no front-end, back-end, and database monolithic architecture. This is basically distributed system of different small dwarfs working for you, and they are doing their job. In the conclusion, the microservice is helping you to increase in the fine grained way the modularity of the system. So you can add, you can disable some microservices, you can scale them, you can basically work with them as a single modular unit. So the circle of microservices, this is a little bit related to the DevOps approach. First, we need to explain the small details of microservices and their relationship with the DevOps or DevSecOps environment. I put in this circle of microservices really simple stuff that you can test with the security tools. It's a source code review, because I know that lots of people from testing, they are doing the regression testing, the functional testing, non-functional testing with the performance. But in the security world, we have lots of different tests. We have network security testing, we have web application testing, we have, for example, encryption testing, we are testing SSL layer. So lots of things. The three main parts of the security testing is static, dynamic, and interactive analysis. Static analysis is about source code review, so we are digging deeper in the code and trying to find the vulnerabilities there. Dynamic analysis is about testing the software itself, running, and trying to put there some malicious input to try to a little bit hack it. And what is really interesting, if you look, there is new word. I don't know if you know chaos testing. Raise your hand if you know chaos testing. Have you heard about that? I want to know how many people are aware of that. Okay, not so many. Chaos testing is a new approach from DevOps environment, basically attacking or disabling your production systems. These production systems, you are trying to simulate the CPU load, disable the production systems, and you are testing your scaling. You are testing how your system behaves under the attack, under the problems, under the chaos. What is really interesting platform for chaos testing is Gremlin. Do you know Gremlins? Have you heard about Gremlins? Do you know the movie? Yeah, okay. So that's good, because if you Have your phone in your hand? Let's try to Google a little bit about Gremlin. Gremlin is a really cool platform for disabling your production systems, and you can even disable whole site. That means that you can disable whole data center or some microservices, which is really cool because you can go from small to the giant level of testing. And I put there a really interesting thing, which is I'm trying to mention why we're talking about the DevOps and all of these things is time. We as a people, we have only thing, it's a time. You don't have money, you don't have anything else. We have time, we are providing the company the time, we are trying to deliver on time, and our customers are demanding these things really fast. And to deliver really fast, we need to automate all the processes. You need to have some pipeline, you need to have some Jenkins pipeline which do automatically all the tests. And this approach is about how to build the microservices, call them from your automated ways, and build it specifically for your software. Now, I put there 3 important points. It's about how the job is changing. Because I'm working as a security engineer and security architect, and usually I get in the request for the job, if someone sends me on LinkedIn, for example, offer for a job, they are asking me for the risk management, coding and testing and all of these things inbound in one package, and they're asking for everything basically, which is sometimes scary. And I realize that the job as we know it is changing. There is no QA, there is no developer, there is no architect anymore. In the DevOps environment, you need to be all of them, and you need to utilize all of your skills. That doesn't mean that you will be developers everywhere, everyone will be developer, or everyone will be just a tester, but the roles are a little bit blurry now. You are not just an architect, you are not just AWS architect or cloud, you are trying to help people to do your best. This is what I call hands-on architecture journey or architect journey. So here is an example of the microservices. The example tool chains. Not everywhere is there, we will go dig deeper. Maybe some of them you already know. There is OWASP Zaproxy. Do you know OWASP? Say yes if you know OWASP. Perfect. OWASP is Open Web Application Security project, and they are focusing on security of not just web applications, but they are now trying to dig into Java, they are digging in the mobile applications. This is really cool that this initiative is here. And in the Docker or any other small component, if you will say it, in the pod, in the microservice, in the small application, you can put Burpsuite, Zaproxy, Arachne Scanner, SQL map, Nmap, all of these things which are helping to discover the security flaws. And then you can call them with some automated engine, like Jenkins, Bamboo. You can use, for example, Circle CI, the automated pipelines for the development, which have different stage. Whenever the developer will deploy the code with your Git or SVN or whenever you use in your company, and then it is automatically built, you can have different stages of testing. And you can call these nice things together in a Docker or Kubernetes environment from your CI/CD. Or you can use business process modeling automation. You can model the process, and you will call the API of different containers. I'm a big fan of comics, so I will not hide that. The presentation is called Unbound, and this is from Superman Unbound. So I want to show you that people are usually not using the technologies as they should use them. I will talk about the penetration testing, about the continuous penetration testing, because this is something what the microservices can provide you. Basically, penetration testing is done on the end of the project. Everyone knows that. You know that there's not too much time to do the quality. Sometimes it's because of the time restriction, sometimes because of the budget pushed on the back. And penetration testing is one of the most underestimated parts. And we will talk about the continuous security delivery, continuous security testing, and continuous penetration testing with the microservices in automated way. How to do that, how to discover all of these things, we will see. I will show you a few different tools, like Burpsuite, a new one, new version of Burpsuite, because it's a really famous tool. Do you know Burpsuite? Perfect. That's a penetration testing tool, and a new version allows you to expose the API, and we will talk about the mobile testing and web app testing at all. So let's move forward. Here is something what I found as really interesting. I will not hide that I'm a fan of open source, and if it is free and I can a little bit change the code and work on that, I'm currently working on experimenting with the mobile security framework. It's open source project which has API. This API can be exposed through the container. You can run it in Docker. I hope that everyone knows what is Docker. At least you have heard about that. You will put this nice tool in Docker, and there is API where you just put the file, APK or IPA file from the Android or iOS device, and it will analyze for you from the security perspective the application in the mobile phone. It will tell you what are the permissions of the application, if it is not dangerous, if it is not asking for fingerprints. I really do not want to expose my fingerprints to third party. What is the source code review? So it will do the source code review for you. It can do some checks. It will basically do all the hacking steps for you. It will decompile the application to the code, look at the code, and tell you if you are using the strong encryption, good cipher suits, and all of these things are reported to you in JSON file or PDF. So you don't need to care about anything. It's a security as a service, and this is how it should be. We should build the services which are dynamically based, automatically testing the environment and providing the output based on our requirement. Basically, whenever I need it, I will get it. It will be never like in Avengers Endgame that you will just snap with your fingers and you will get everything. There is sometimes some work needed to be done, but basically you can automate lots of things. What is cool on this tool, there is even the dynamic testing part, not just the static one. There is a fuzzing API called CapFuzz. So if you will capture the communication between the mobile phone and server, you can do some fuzzing over that. Do you know what is fuzzing? Okay, it's basically about sending the random or constructed input to your parameters in your application. So we are trying to fool the application. We are not sending the valid input in the app, and then you are checking the behavior. So this is how it looks like. Basically, it's not the best tool for like nice reporting, but it gives you in like 25 seconds to 30 seconds if you have enough CPU and memory, and you don't need too much. It gives you full report of the findings. Yeah, I choose the IBM application because it's free and it's exposed as a vulnerable application by default. So very interesting thing and very cool thing is the Unbounded Security selected microservices. What is the secure code box? I want to do this. I want to show you the architecture of this tool. It's really cool stuff because it utilizes different Kali Linux tools or OWASP open source tools. I didn't done this application. It's basically on GitHub. So if you want to check how it really works, you can go to GitHub and check how it is built. There is Camunda BPN, basically workflow management, which is calling the APIs of different tools. Some of these tools are part of the Kali Linux. Raise your hand if you have heard about the Kali Linux. Okay, lots of people. I'm surprised. We have lots of hackers here, which is really cool. When I'm testing our applications in Thales, I discovered that we have the same problems all the time. I'm running similar scripts with similar parameters, and I want to automate it. I just do not want to have the Python script, which is repeating everything, but I want to have all of these tools like VPScan, Zaproxy, Nikto, SSL testing, out of the box. I want to automate it. I want to say for this application, I want to test the mobile app. For this application, I want to test the front-end web application and port scan. And how I will do that is with this amazing tool. You can even integrate it with Jenkins, which is CI/CD, continuous integration, continuous deployment platform. Or SQL, what is really cool that they are working, I want to mention that, they are working on SQL map integration. So you will be able to test an SQL injection in your web applications or mobile apps. And that is by default, it's enabled to help you to integrate it with the Burpsuite. You can see that this is built on Docker. All of these things are built on Docker. I don't know if it is a little bit blurry. But you just spin up every of these pieces of the architecture in Docker and call the API. How it works? Let's go some demo. I will show you some examples how it works, because I like to show you real-time, real-world examples. What you will see here, it is built on cloud. Everything is built in AWS. I'm a big fan of AWS, so I say, okay, let's spin up some Elastic Compute Cloud, put there some Docker containers, and utilize all of these nice dwarfs working for me and doing the penetration testing. This is Camunda. If you don't know Camunda, Camunda is a business processing workflow management. It's automating the workflow of the task that you want to perform. It can call the API of the Docker containers. There are three main parts. It's cockpit, task list, and admin. So you can basically have even the user management in your application. And let's go to that. Let's check it, what it can do. If you will check the cockpit, I hope that we'll have good connectivity. The problem with the internet here is a little bit tricky. You have the running instances, so you will see how many tests are you running now, how many tests are failing and why, and then some open tasks. Because usually when I get some results from the test, I want to review them. Some of them, they can be false positive, and you know that with the ZAP proxy and similar tools, you get high ratio of false positives, and you need to a little bit analyze it. Let's check what we have there. Running processes, you will see which processes are failing, which are running well, which tools are already integrated. Really cool. Everything in Docker, everything in the container, everything as a microservice. Really great. If you want to check how it works, you don't need to be developer, you don't need to be the science engineer, you don't need to be like rocket engineer to see how it really works. For example, I will choose one of these nice diagrams, SSH scan, which is really easy. You build your test in the BPMN. Do you know business process modeling notation? Some of you maybe yes. You basically define the workflow of whole test, and in the boxes you can say, I will call this API, I will call that API, and at the end I will review that. Really good. You can see the incidents, what happened to your workflows. There are no workflows, it's some job definitions which are already running. And if there is some incident, if we'll go to the processes, I will choose the NICTO web scanner. You will see where it stuck, which part of the process in your testing it doesn't work, and why. So let's check the incident. I don't know if you see it well, but it failed to read the NICTO result. And then you can do some research what is wrong and what doesn't work. That's not everything, because you need to gather some results, you need to call different microservices. So let's check the task list, because after this test is completed, the results must be approved by you, because everything shouldn't be done just automatically. As I say, that is not with the snap of the fingers, sorry. Here you have ZAP scan results. It's basically like a Jira or similar task management. I hope that it will load. It's because of the slow internet connectivity. And here you have all the results parsed directly to the Camunda interface. So I have all the results from the application scanner. I can see what are the findings. And I can say, okay, I will take this task to myself. Now it is assigned to me, Marek Šottl, and I can approve it, or I can say, guys, let's do this test again because it's useless, or disapprove it. So basically, at the end of the findings, there are many findings. You can say approve, not approve, and you can change the configuration and restart the test. Because in the BPMN, you are defining the parameters for the APIs of the microservices. So easy, really easy stuff. So I will say approve, complete, and what is going on with the results? Because I have results from different tools, from different Kali Linux tools, from Nmap, from NICTO, from ZAP proxy, and I want to know everything in one place. So let's put it in Kibana, or put it in one database in the structured format that I can control. If you will have enough data from enough tools, you will have a huge database of the vulnerabilities. And with this huge structured database, you can do some research. You can search for the data. If you have enough data, and it was today really massive about the machine learning, if you will have enough data, you can even do some prediction on the data of your system. So let's check the Kibana. All of these things, all of the findings from these different microservices are going on to Elasticsearch, Elk Stack. I hope that everyone from you heard. about that. That means that this Elasticsearch, Logstash, and Kibana, this combination brings some good monitoring tools. But in this case, we are using that as a reporting tool. We parse all the data from these tools, from the microservices, put them in one database, and continue with some research. Here you can see, if I will click in the data, you have here raw data, everything what was sent to the server, all the parameters, recommendations, which tool did it, and what is the CV, what is the common vulnerability and exposure number. So full reference to some specific finding. And I say, okay, that's the data. Someone likes to play with the data, but I want to visualize it. You have different options how to visualize it. In this tool, the Secure Code Box, you have pre-visualized some host port review, for example. So you want to know what is the most common port open on your services, how hackers can go inside of your system. And if I will do the penetration testing, I will start with the Nmap. I will start with the port mapping. I want to know what ports are open in the system to get inside. And this is done automatically. This is really great. I see the IP addresses which are tested and what ports and what protocols are open. But this is not enough. I say, okay, Marek, let's create some cool DevSecOps dashboard and do some visualization on the data. So I'm able to distribute different severity of the findings. I'm able to see what are the most significant findings on which level of the network. If it is application, network layer, whatever layer, I can dump the data and I can play with them online. That means that in real time I can little bit play with the data structure. I can change the dashboard. For example, there is a huge subdomain number of scans. So I will say, okay, I don't want to see that. Inspect. And I'm not interested in subdomain scans. And you see that the data changed just right now. And I have findings, the prominent one, overall findings at different level, overall findings by severity, the port distribution in the systems, so I can see which ports are open in my systems in some nice graph, and the recommendations. So I can take the description and recommendation from the tools in one place, and there are different tools. This is really cool. That's really amazing because you can just spin up different Docker containers with different tools, gather them in one place, and analyze it. And if you will look at the user management, because I remember one call with our validation engineers, they told me, yeah, Marek, you exposed one Docker container out and there is no authentication. With this tool, if you will go there and there's admin, you can assign the specific roles and specific user rights to the system. You can manage the authorization and to everything, to the task, to the batch, to the deployment, to the engine, APIs, you can assign the roles. It is role-based access control. Really great. So this is something what is going on now. This is no future. It's really cool automation way how to get the data. It's not for replacing the penetration testers, but it's helping you to dig in the security in the early stages of the development. It provides the security by design and security basically on the beginning of the development. You have first release or first build and you can test it. So that was first demo. Then we will talk about the Burpsuite Pro, Burpsuite Pro 2.0. I have to say that many of you already play with that, and everyone is hacker, so you can go here and take it for me. New version of Burpsuite exposed the REST API, which is really cool, because this is something what I was missing there. There is a Java API, but for the new version of Burpsuite, there is a REST API. So basically, I can put this Burpsuite in the Docker container and expose the API to the world or to Secure Code Box and use it out of the box as, like I said, small single unit which will test everything for me. And this small unit will be testable, maintainable, and I will be able to separate it from the others. So that means that I will be able to use it as a standalone solution. Let's check again how it works for the Burpsuite, because I like demos. So there is a new feature that you can enable the Burpsuite API. You can define the port where it runs. You want to, for example, say that it will run in different port than the default. You can do it really easily. And I'll show you that really fast demo. It's no big deal. In the user options here, in the MISC, there is new stuff, REST API. It was not in the previous version. You can say that on the local host, on some specific port, there will be exposed the REST API. You can open that. And it's really nice API. It's like really simple. You can get the scans, you can call the scans, you can get the results in the structured format. If you want to, for example, to define some specific details of the scanner, you can click on scan, and then it helps you to extend the application parameters or the REST API parameters. So you can do authenticated scans or specific type of scan, SQL injection, cross-site scripting. You can focus on one small piece of security testing. So it was just like a small example how you can expose new API of Burpsuite, just to know that it is possible now, and I'm looking forward to use it in our company. That is something what I call microservice journey, because these experimental solutions, Docker, and Kubernetes, and cloud, are really hard to explain to the management. They are not listening sometimes. They say, yeah, that's new stuff, we don't need it, it will cost money, and everything like that. It will never happen from today to tomorrow. You need to experiment a lot. Visited few AWS conferences and read how they work, and I saw that they experiment a lot. They learn on experimenting and failing. If you will not try that and fail, you will not get any lessons learned. These rules are basically related to the culture, because you need to change your culture in your company. You cannot do waterfall and use SOAP UI all the time and specific time and in a period that you want to do the integration testing. You need to change your mindset. You need to understand that the market is changing and the world is changing, and engineering approach is different than before. Without research, it will not work. I have one colleague, and I really like him. He's complaining all the time that he don't do research. And he's correct. We need to do the research. We need to look on the market, what is there. All of these tools that I'm showing you are for free. You don't need to pay for them. It's for free. It's open source. So basically, if you didn't start to participate on the Secure Code Box, let's do it now. Go to the GitHub and code some stuff. So back to the tools. You need to evaluate these tools. You need to do some research, evaluate them, and you need to plan in small steps. Because I was working for the company who say, let's do the big bang, let's put there all the stack of the DevSecOps tools, and we failed because we didn't plan on small steps. We didn't say, okay, let's build first stage, let's build some small virtual private cloud, and let's experiment. Because we did it big, we failed. And that was lesson learned. So then we started to do small steps and small planning. And you need to explore your CI/CD. This is really important. Continuous integration and continuous development. Everyone use different CI/CD platform. You have different stages of build and different testing. And it must be fit to purpose. I will repeat it. It must be fit to purpose, because there is no solution which will save everything for you. You need to choose the right microservices, right tools which are helping your application. Testing the database where there is no database doesn't make sense. And there are some people who are running some database tests. And continuous security testing, that's a really important thing. The world is changing. There is continuous development, continuous testing, continuous integration, and there should be the continuous security testing or continuous penetration testing. We will never replace the penetration testers because they need to dig deeper and dig deeper. But for the low-hanging fruits, these tools like Codebox, Mobile Security Framework, or Burpsuite will help you a lot. And if you will automate it, it will help you even more because you will save a time, and cost effectivity in the time, or time cost effectivity, will help you a lot to focus on important things and do the creative tests. How to deploy it? Usually, I'm, as I said, AWS guy, so you can use different platforms for deploying the container services. You can use Helm, you can use Ansible, you can use CloudFormation, which is basically script language for AWS. You can use Troposphere, because we are using our company Troposphere, which is basically based on Python and generates some scripts to run the instances in AWS. You can use Azure Resource Manager for the guys who likes Azure. Who is here? Who use Azure here? Okay, not too much. And who use AWS? Okay, more interesting. So maybe you will know these things. Maybe you will have heard about that. But there are like 4 to 5 important steps that you need to check the configuration. If you will build the code or infrastructure as a code in these scripts, In the cloud environment, the Docker environment, you need to check them. You need to do some assessment of the microservices or microservices. You need to use Docker Bench or KubeBench. I will show you these tools. Depends on the time. And you will see that it is really easy to evaluate the security of the containers itself or the microservices. Then you need to do some automated security testing. You need to apply these changes. And if you will be able to build it and have it hardened, that means hardened image. We are using Helm for managing the containers, which is a really interesting platform also. You will be able to provide them as a service. Security as a service is my ultimate goal. Developers or validation engineer, they should use whenever service they want, whenever time they want, in the secure manner. I know that this is different way of thinking than the usual security approach of the risk management. But if we will build the environment for you as a validation engineers, for you as a developers, whenever you will want to use anything, it will help you a lot. And penetration testing as a code is another chapter, which is very interesting too, because Zaproxy have something called ZScript, and you can automate even and deploy all the penetration testing steps, or at least some of them. You will see that very interesting here, the code here, very interesting stuff is CloudFormation. I'm trying to explain the differences between YAML and JSON. YAML is basically YAML in a markup language, and JSON is JavaScript object notation. You will see Java object notation. You will see that the more readable is the YAML file. It's like a shopping list. If you want to go to grocery store, you just order the stuff. This is a CloudFormation script which deploys the containers in the cloud, basically now in Amazon Web Services, and defines the ports where we want to expose it. Defines the application and container port. And I say that it's really easy to write this code. It's no programming. Basically, you are ordering that what you want to build. And it is readable for humans, and it is readable for machines. Machine and human readable languages are the future of deployment of the cloud, of the microservices, and the applications itself. And cool stuff on that, you can have different versions. You can use Git to version that. You can have different versions of infrastructure and deploy different version as you want. Or you can roll back to that. It was not possible before to roll back to the different version or minor version of your infrastructure. So let's secure the security, because we have something called corporate security, because I'm a product software security architect, and they sometimes came to me, hey Marek, we found your image, and it's not hardened enough. I say, okay, so let's do something with that. Let's secure the security to make everyone happy in this planet. Securing the security means that we need to secure somehow the containers itself. We need to take care about there will be no leakage of the data from our microservices. Do you know the CISSP, Center for Information Security or Internet Security? Have you heard about that? CISSP benchmarks. This is like a benchmark which defines all the steps that you need to take or you need to go through to secure the Kubernetes, to secure the Docker, Windows images, all of these things, and there are tools for that. If you will look at these 4 or 5 areas that are defined, runtime security is really important. In the container world or microservices world, it's more important to secure the application itself, because network is based on another level, it's OS level, and it's a different way how to secure it. If we will look at the runtime security, there are some tools which help you to do some analysis, like SysDig. And if you want to do audit of images inside of that, there are many tools. Many people are now working on the auditing tools. We are experimenting with the Docker Bench. I will show you that in a few minutes. You will see how Docker Bench is super easy to run on the host environment, and it will tell you what's wrong with your containers, what's good with your containers. Really interesting is KubeHunter or KubeBench. So basically you are checking the image inside. Secret control is for Thales because we have some cloud services and we have some shared secrets, certificates, passwords. And what our developers sometimes are doing, they hard code the password, and we want to have some secure storage for our containers, for microservices. And if you will look at Vault, it's a really interesting platform for dynamic storage for the tokens, passwords, certificates, which can be on demand provided to the container services. Really interesting stuff. And image scanning. Image scanning is the next part. The code inside of your Docker or your Kubernetes pod or whenever microservice, it can be Spring Boot or another type of microservice, you need to do the source code review. I like a little bit Snyk because it's easy to connect it to the GitHub, but you need to do the source code review of the application itself and check how the application from the security perspective is built. There is Fortify, checkmarks, or other tools which are not the microservices, but they can help you to evaluate the code itself. What is really, really interesting, and I will mention to that here, it's a network. It's really hard to build security of the network of the secure containers. How to separate them on the network, how to say that these ports are open or disabled. There is cool platform called Istio. Do you know Istio? Have you heard about that? Someone raise a hand. 1, 2. Okay, I don't see that because there's too much light. 3, maybe 3 people from here. Istio is a mesh management platform. So we have a distributed network of different containers, and from one place you are managing the mutual TLS communication. You are managing different proxies. You are managing the PKI. You can detect the man-in-the-middle attacks. And there are really interesting, like 4 parts of this Istio. There is a proxy, like ingress and egress, incoming and outgoing traffic, which can be authenticated, mixer, which is helping to do authorization of that. That means this is roles-based access to the containers. And then there is a Citadel, which is taking care about the certificates itself. And Pivot, which is for authorization. You can use different identities to get in the containers. You can have Kubernetes identity, Google Cloud identity, Amazon identity, or on-premise. That's really cool. So some use cases, because I don't want to show you just theoretical stuff, I will show you 2 different implementations. I like this diagram. If you don't know Cloudcraft, I can recommend it really well because it can do the 3D models of the infrastructure, and it can even estimate the budget for you, how much it will cost you. In this diagram, you will see that with the microservices, in this case, Elastic Container Services from AWS, you can deploy your container, and there is a Lambda. Have you heard what is serverless? Do you know that? Have you heard about serverless? Raise a hand. Okay, good. I'm surprised. It's better. So I'm happy for you. You can have Docker Bench Lambda or Kube Bench Lambda, which periodically connects to the Docker, do the benchmarking, and report it. You can use SNS, you can use email service, you can have Elasticsearch consumption, or S3 buckets, which is basically Amazon object storage, where you can store your data. And you can have automatic system, which will tell you what is the health of the container. I remember that my colleague, he gets a cool idea, let's disable the containers if they will be not compliant. And then we discovered that all the containers are not compliant, and we will disable all the containers. So then we just stick on just a notification, and we send the email to the team, hey guys, you need to stand and you need to do something. So this is one of the examples how to solve it. And using the microservices, it's another interesting architecture that you can use. Basically, you have the Jenkins or any other CI/CD, Bamboo, Circle CI, whenever you like, whenever you use and feel comfortable with. Then you connect to the API gateway, and with this API gateway, you expose the APIs of your microservices. You put them in one cluster. It can be Elastic Kubernetes service, it can be Docker-based Elastic Container Services in AWS, or it can be even in the Microsoft Cloud, the Azure. So you can build it even on-premise on OpenShift. And you expose through the API gateway all the APIs of these different microservices, and from Jenkins in your different stages of your development, or this CI/CD, or this continuous deployment, development, you will call different tools. For example, you will build it, then you will call source code review. After the source code review, you can call web application scan, then the port scan, then you can call the Docker control or Docker benchmark. So before we will end absolutely, I will show you how easy it is. I hope that I didn't disconnect myself. Yes, I'm disconnected. as I expected. So I will reconnect myself. We'll see. Oh, no, it doesn't work. It is really, really easy. I will make it bigger for you to see that, because I know that the small letters are not for everyone, and not everyone is sharp in their sight. Okay. Do you see it better? I know that this is not bad in this dark environment. I'll try to, Then what I should do is basically, I will go to the directory where I have Docker Bench and run the Docker Bench script. It's on GitHub, so if you want to check how it works, there's kubebench or Docker Bench. It is checking your instance against the CIS benchmarks, or Center for Internet Security. And as you see, it was really fast. It was faster than I expected. It gives you all the recommendation, what you should do. It will tell you where you fail, where you pass with your microservice, and what you need to do to do some remediations, what actions you need to take. So you see, for example, here that you need to ensure the Linux capabilities are restricted within the containers. You need to check the access rights to your network interface. You need to check the namespaces between different containers running in one host. And you can have really fast results and remediation recommendation. All of these recommendations are here, and they can be consumed by Elasticsearch and analyzed. So it is really easy. It's no big deal. It's no big science. And that's for today. I think that's enough, because we can talk a long time about that. And thank you for your time.
All right. Thank you, Marek. Now it's time for questions from our audience. First question, please. Could you advise what argument we can bring to higher management in order to convince them to invest in containerization and microservices? From Mateusz.
Okay, that's really great question. It's for every environment and every company is different. Depends what is your business. Good is to find some small use case, really small use case which will be not painful, and then present it to the management and try it. Try to say what will be the cost saving, what will be the speed up. You need to explain how fast and what will be the differences against what you are doing now. For example, if you have monolithic architecture and monolithic testing, and with the secure code box, for example, if you will present that I want to utilize these services for the testing, how fast you can get the results. So there are different approaches how to present it to management, but try to show the cost savings and the time savings.
Okay, thank you. Next question. What problems can company experience in process of automating security tests? From Pavel.
Yeah. So if you will use Gremlin, as I showed you, you will have lots of problems, because it will basically intentionally destroy your production environment. But if you will do the security test, you need to be aware what you are doing. For example, if you are sending to the APIs of these microservices specific parameters, you need to know what you are doing and not destroy your environment. I will give you an example. I did some tests a few weeks ago on one of our systems, and I started to send there so many requests, and the system was not ready for that. So it is good to set up some scope and limitations of the test and define what will be not the part of the test, what will be excluded, and do not do any DOS attacks.
And I think the last question, very quickly. When it is not a good idea to use microservices, and why?
All the time is good idea to use microservices, but okay. Again, it depends on the architecture that you have. If you have old systems, okay, you can have old banking system, you can have old electricity grid management system, then you will not use it, because the system is so old and it's working on different protocols. For example, when I work with telco, we use SS7 protocol, and you will never use microservices on the protocol which is not IP based, for example.
Marek, thank you very much. It was
the
last questions. Thank you. Ladies and gentlemen,
thank you.
Marek Šottl. Thank you.